Viking Mission to Mars. The first U.S. mission to land a spacecraft safely on Mars and return images of the surface was NASA's Viking project in 1976. There were two identical spacecraft, each consisting of a lander and an orbiter. Each orbiter-lander pair flew together and entered Mars orbit. The landers then separated and descended on the planet's surface. The Viking 1 lander landed on the western slope of the Planitia, the Plains of Gold, while the Viking 2 landed at Utopia Planitia. Planitia is a smooth, circular plain in the northern equatorial region of Mars. It is 1,600 kilometers in diameter and with a floor of 2.5 kilometers below the average planetary surface altitude. Planitia shows evidence of water erosion in the past and is the bottom end for many outflow channels from the southern highlands. It is one of the lowest regions on Mars, so water would tend to flow into it. Several ancient river valleys discovered in Planitia by the Viking orbiters provided strong evidence for a great deal of running water on the surface of Mars. Utopia Planitia is a large plain within Utopia, the largest recognized impact basin on Mars and in the solar system, with a diameter of 3,300 kilometers. Many rocks at Utopia Planitia appear perched, as if wind removed much of the soil at their bases. A hard surface crust is formed by solutions of minerals moving up through soil and evaporating at the surface. Some areas of the surface exhibit scallop topography, a surface that looks like it was carved out by an ice cream scoop. This surface is thought to have formed by the degradation of an ice-rich permafrost. There are many features that look like pingos on Earth found in Utopia Planitia. On November 22, 2016, NASA reported finding a large amount of underground ice in the Utopia Planitia region. Pingos are intrapermafrost ice-cored hills, 30 to 70 meters high and 30 to 1,000 meters in diameter. They are typically conical in shape and grow and persist only in permafrost environments such as the Arctic and subarctic. Pingos are formed when water, rising by hydraulic pressure through gaps in the permafrost, freezes and uplifts a mound of ice covered by a layer of alluvium. Alluvium is loose clay, silt, sand, or gravel that has been deposited by running water in a stream bed, on a floodplain, or in an alluvial fan or beach, or in a similar setting. Besides taking photographs and collecting other science data on the Martian surface, the two landers conducted 3 biology experiments designed to look for possible signs of life. These experiments discovered unexpected and enigmatic chemical activity in the Martian soil, but provided no clear evidence for the presence of living microorganisms in soil near the landing sites. According to scientists, Mars is self-sterilizing. They believe the combination of solar ultraviolet radiation that saturates the surface, the extreme dryness of the soil, and the oxidizing nature of the soil chemistry prevent the formation of living organisms in the Martian soil. The Viking mission was planned to continue for 90 days after landing. Each orbiter and lander operated far beyond its designed lifetime. Viking Orbiter 1 continued for 4 years and 1,489 orbits of Mars, concluding its mission August 7, 1980, while Viking 2 orbiter functioned until July 25, 1978. Because of the variations in available sunlight, both landers were powered by radioisotope thermoelectric generators, devices that create electricity from heat given off by the natural decay of plutonium. That power source allowed long-term science investigations that otherwise would not have been possible. Viking Lander 1 made its final transmission to Earth November 11, 1982. The last data from Viking Lander 2 arrived on Earth April 11, 1980. The primary mission objectives were to obtain high-resolution images of the Martian surface, characterize the structure and composition of the atmosphere and surface, and search for evidence of life. Viking 1 was launched on August 20th, 1975 and arrived at Mars on June 19th, 1976. The first month of orbit was devoted to imaging the surface to find appropriate landing sites for the Viking landers. The orbiters imaged the entire surface of Mars at a resolution of 150 to 300 meters and selected areas at 8 meters. The lowest periapsis altitude for both orbiters was 300 kilometers, the smallest radial distance of an ellipse as measured from a focus. Taking in the equation of an ellipse gives the periapsis distance. Periapsis for an orbit around the Earth is called perigee, and periapsis for an orbit around the Sun is called perihelion. The Viking 2 orbiter was powered down on July 25, 1978 after 706 orbits, and the Viking 1 orbiter on August 17, 1980 after over 1,400 orbits. The Viking landers transmitted images of the surface, took surface samples and analyzed them for composition and signs of life, studied atmospheric composition and meteorology, and deployed seismometers. The Viking 2 lander ended communications on April 11, 1980, and the Viking 1 lander on November 13, 1982, after transmitting over 1,400 images of the two sites. Many of these images are also available from NSSDCA online and as photographic products. The results from the Viking experiments gave our most complete view of Mars. Volcanoes, lava plains, immense canyons, cratered areas, wind-formed features, and evidence of surface water are apparent in the orbiter images. The planet appears to be divisible into two main regions, northern low plains and southern cratered highlands. Superimposed on these regions are the Tharsis and Elysium bulges, which are high-standing volcanic areas, and the Valles Marineris, a system of giant canyons near the equator. The surface material at both landing sites can best be characterized as iron-rich clay. Measured temperatures at the landing sites ranged from 150 to 250 degrees Kelvin, with a variation over a given day of 35 to 50 degrees Kelvin. Seasonal dust storms, pressure changes, and transport of atmospheric gases between the polar caps were observed. The biology experiment produced no definitive evidence of life at either landing site.